We have our next presentation here. We're going to introduce Niels from a company called Criipto, and he's going to be talking to us about FIDO for web wallets and digital identity. Just as a reminder for people who are on the live stream, there is an option for putting in questions that will be looked at as we have time at the end of the presentation. And if you have additional questions that don't get answered, or if we run out of time, or you just would like to chat with Niels after this is over, we do have a speakers area, which is all the way down the hallway. You'll see several large white rounds around there, and Niels will be there after the presentation to chat and answer any questions. So take it away.
Thank you. Okay, I'm Niels. I'm from a company called Criipto. And just to get it out of the way, Criipto is owned by, and this was a recent acquisition, owned by Norwegian Bank ID, which runs Norwegian digital identity infrastructure. So I'm speaking from a perspective of Criipto, which is sort of a broker and like Stripe for credit cards. We are the same thing for digital identities. And then also from the perspective of Bank ID, which is the Norwegian identity, the most prevalent Norwegian digital identity. So staying in Norway, the police has a separate unit on financial and cyber crime. They came out with this report, which you don't see. So I was wondering, should we? Okay, so everything I said, just bear with me. Let's see, should I? So my thing here has a different slide. I don't think it's out of sync. Let me go back here. Nah, it has no effect up there. Can you make the? Oh, there you go. Yeah, we did that. Okay, so the financial fraud thing. Yeah. So this is, a wall of text to say that phishing is a big thing. People are not breaking into our data centers, they're cheating our users out of their money. That's the essence of it. And this is the right audience for a message like that, I know, which is why I thought this was the place to say it. And as an example, in Norwegian, this is a test for those of you that understand Norwegian. No, the Norwegian police broke up this crime ring it had its origin in Romania, as you may be able to pick out. So Romanian gangs would send out SMS messages that appeared to be from the Department of Motor Vehicles in Norway, and they would cheat people into handing over their digital identity. Traditional phishing, type in your username into a page. That's the purple box there. It says social security number. And you type it in, not aware that you're actually typing into a fake page, and then it all happens and your money's gone or something. Tongue-in-cheek, you can say that in Europe, and we'll get into that a little bit more, legislators and regulators are more concerned with they want to build something so you can't break into the data center, because you don't want criminals breaking into your HSMs and all that. And of course, we need all that data center security. But without it, or even if we have that, they can still phish you. So Romanian gangs will just have to live with that. That's where all the action is, but at least we know our data center is secure. And here's an example of what digital identity is. And for those of you that are not from the EU, and especially if you're not from Scandinavia, I'm from Denmark, the digital identities we have are in Scandinavia, we use them all the time. It's like using your Google or something. People go to their digital identity every day, several times a day. Swedes do it about 40, 50 times a month. The one example here on the left is a central service. It looks like that every time you authenticate to some website. That's the Belgian It's Me. In the middle, it's the Finnish one. It's in the category of click the logo of your bank. I think in the US, FIDO may have something like that, where you can go to you basically authenticate with your bank, and from the bank's perspective, they can leverage that big asset they have poured so much money into to do KYC. Now they can use it outside of the bank and sell it for money. On the right-hand side, all the smart card-based solutions and Germany and Spain. Germany has something called Personalausweis, which they use, and these days you can hold it to the back of your phone, but it's a cumbersome process. Digital identity succeeds when it looks something like this, when it looks the same no matter where you go. This is a Danish digital identity. There's a box, and it looks the same in different different clothes, but it looks the same all the time. It is recognizable, and there's an app that goes with this that you carry on your phone, and you use it every time to approve. So it's a two-factor thing. And this obviously is ripe for phishing, and that's exactly what happens. The one on the right-hand side is the big bank in Scandinavia, Nordea. The one on the left-hand side looks like the big bank, but it's not. So if you look at the URLs, guess which one is the legit and which one is not. I can say that cprapid.com is not the official site of authentication my wife stepped into this one. So she got a text message saying, you just used your new credit card, and she actually did. They sent it out to 1 million people. So, and you need to click this link, and she's an art historian. She runs a contemporary art gallery, so she knows nothing about URLs. And the government has this idea, they do the EID, that this is really cool because everybody will just recognize the URL mitid.dk, that's the official one, and they'll see immediately that the one on the left is off. So, of course, my wife would never step into this one. Fortunately, so she let in the hacker. She types in her name, she gets on her phone a ping, she has to approve it on her phone only. It's the hacker typing it into the real bank, phishing. So she actually let the hacker into our web bank, and then she realizes something is off. So she calls me, and fortunately we were switching banks, so we still had two banks. So we transferred our money to the other bank before anything happened. And also you have to do a second approval to transfer money out of the bank. So he didn't succeed, he or her, probably he, 22 years old, bling bling, all that, with one of those phishing things. It doesn't exactly take brains to be a phisher. Governments, on the other hand, are not concerned so much about this. The regulators are more concerned with, are you buying enough hardware from the big vendors? That's, paraphrased a little bit, but that's the message. So Criipto, the company I run and founded, we are a broker of these different IDs, and that means there are a lot of requirements for how we have to do that. And this is an example. So our customers are relying party service providers. They connect their apps to our service, just like you connect to Auth0 or Ping or Keycloak or something. And then we broker all these EIDs. We have to do it this way. This feels good. It's almost bike shedding, where you focus on something you can get your hands around, your head around. So you do this and you feel good about yourself. You still have a field on the website or on the screen where you have to type in something extremely phishable. But at least you have bought expensive hardware, and so we did. And another thing with the regulators is in Europe, this concept of digital identity that's tied to your legal identity, your physical, as a physical person, is regulated by something called EIDAS, European Electronic Identity and Trust Services, something like that. And that's something we spend a lot of time and a lot of money on. These are examples of your language that shows why passkey is having a hard time in that environment, because passkeys are having a hard time in that environment. For instance, you can only have one copy. So with sync passkeys, it's kind of tricky, and regulators, my friends from Norwegian Bank ID were here a year or two ago, complaining about how sync passkeys have spoiled the opportunity for using passkeys in digital identity. But also this concept of signatory, the holder of the key, we should be pretty sure that it's only one person that holds it. And my daughter uses my iPad a lot, and I have my phone as well, and she knows my PIN code. So she could potentially, be me online. So we don't want that. So rather phishing by Romanian gangs than your daughter accessing your bank account. That's the message from the regulators. Okay with gangs, no family members, please. One final thing is attestation. The thing is, you can't prove that the key you use in sync with sync passkeys is kept inside a secure element or the sufficiently secure piece of hardware. Of course you can't. If it's synced, it may be a soft key in one place and a secure element in another place. So attestation, it would be nice to get that back. That way we could move forward with more confidence. So where that leaves us is that, I'm not chalking down the HSMs in the data setup. Maybe we spend too much. Level 2, level 3, that's quite a price increase. If you go from, FIPS 140-2, from level 2 to level 3, maybe we could do with less. But of course we need it. No, the thing is that the regulators and all the stuff we like to talk about and all the attacks and all the fudge is keeping our attention away from the phishing. Now, this environment, of course, we're concerned about phishing and we're doing something about it. And actually, we should focus more on trust of the user experience, because that's also safety and security. How do you feel about it? Are you confident? Are you safe? Do you feel taken care of when you use your identity? Maybe it's not technically the best in the world, but if it's smooth and fast and everything, if we can improve security for the whole population of my small country of 5 million people, that might be better than having extremely good private key based on some device for a few people that are buying a factory or a Rolls Royce or something. So good security on the aggregate, in my perspective, is often better than great security for a few people. And legislators tend to lean towards great security without understanding that means for fewer people. Because if you ask a politician, do you want substantial security or do you want high security? I think I'll take high. I like that. So regulators approach this the same way. If we did that for transportation, we would have cars made of cast iron going 20 miles an hour or something. That's how European legislators go about this. Also, client-side cryptography is back in vogue with our devices. Now we can do the things on our devices that we in the past would have to do in the data center. That introduces decentralized identity, or more commonly talked about as wallets, because now we can do stuff on our devices and get credentials into our wallets issued by trusted sources. So your bank or your government or Department of Motor Vehicles may issue something into your wallet that you can then use later. And that's the thing that's different from federated identity. You get something into your wallet, you carry it around for a month, and then you use it. So the DMV may have shut down after they issued your credential. It's still in your wallet, it can still be used. That's the idea. So, this way, with our new devices, we can have a credential issued into our wallet, and we can cryptographically later present it to a verifier, as it's called, a relying party, to some website. We present a credential out of our wallet. The beauty of this is, with the cryptography we have today, is that not only can the verifier, the website that's being presented with your credential, they can verify that this particular credential was issued by someone they trust. That's cryptography. But also they can verify that whoever is presenting this credential is actually the person that the credential was issued to. That's the client side, because you have a key pair on your phone, on your device, on your YubiKey or whatever. You can then prove that this was the key pair that was used when you received the credential. Then you can prove it's still you when you present it. That's the whole idea of this concept of verifiable credentials, that if you're into identity in a broader sense and federated and open ID and all that, you probably come across that. Here's an attempt of building such a wallet And I know I put a lot of stuff in. If you read the description, there's way too much in there, much more than you can do in 20 minutes. It probably takes 20 minutes to read the description of this session. But anyway, we built a web wallet. We say, okay, so with the limitations of WebAuthn, what can we do still in the browser, remembering that, you know, if you can have reasonably good security for a lot of people, that might be better than this high security stuff in some use cases, most use cases. So this is a relying party. This is your website. It's ugly, but it's very technical. And I say I want to authenticate myself using a credential from my wallet, my web wallet built on WebAuthn. So what happens is that if this works, yeah, there you go. So now we're loading the wallet and it says it's passkey. Passkey unlocks my wallet. It loads the credentials that are in my wallet. In this case, it's just a single one. And this is the credential I want to share. And then I click share, and here's the credential back at you. So now you have a credential presented to you, and all this stuff here, you can verify that it was issued by someone you trust, and it was presented by the person that you thought would present it. So this, and the stuff in the middle, it goes in a loop. The stuff in the middle, it's something called selective disclosure. And we're not here to discuss that. The challenge is that when you have issued credentials into a wallet and they just sit there for a while, and then later you present the credential, maybe you don't want to present everything, your name, your birth date, your state, or whatever, address and all that. Maybe you just want to present your name. Maybe you just want to present that's called selective disclosure. That's what happens in the scrolling part in the middle. And the way you get something into that wallet, create the wallet, again, it's all browser-based. You create the wallet here by clicking the sign up, and then it goes on. If I click something, there you go. Now you create the passkey, which creates your wallet, and then you have to get a credential into the wallet. And what you see here now is that it goes to the Danish EID, which is completely phishable and all that, and uses that, the Danish EID, to issue a credential into your wallet. And this is what the Danish EID looks like. I type in my username in a second here. I type in my username, phishable, and then I go to an app that every Danish person living in Denmark has on their phone, and they approve it in the app. And because of the problems of switching back and forth, especially from app to browser, that's not robust. You have to do it yourself. A lot of people drop off and all that. So you need to keep the wallet in the browser. So if you remember my previous slides, when I used my credential, the simple flow, the thing you do every day, it was all in the browser, no apps, no nothing. Very simple, no one drops off. That's the idea. So introducing one of these wallet things instead of just traditional federated identity, you need a few things. The European Union is working on, or not working on, they passed legislation, and now the member states are working on implementing sort of a wallet-based infrastructure. And I'm sure there are people in the audience, I saw Yubico earlier, they are working on a more advanced version of this web wallet concept in the context of the European Union. You need great usability. If you want adoption, you should focus on usability. That's number one. Number two is, if you want adoption now without the push from regulators, regulators are saying every European citizen should carry one of these wallets, certified, official, blah, 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 in the year 2027. If you want it to happen now, you need to find industries where it makes sense. Today, you are paying per transaction. So any relying party, verifier, website, whatever you call it, they pay per successful logins to these digital identity providers, these EID providers. So you need to find industries where they pay a lot of money for that. And one of those industries is sports betting, because people that do sports betting, like it or not, they do it a lot. So they sign in every day and use this for authentication day in, day out, every second hour when you go and check if Manchester United won that game or not. You do it all the time. So usability, that's key to have adoption, but you need some force behind it. And that's why we chose sports betting as one of the industries where this makes sense. A word on cryptography, and I'm not a cryptographer myself, and this is my feeble attempt at trying to illustrate, so bear with me here. This is once you've set up your wallet. The purple stuff at the bottom is kept in the data center. It's your credential that was issued to you, encrypted, by a key that's it's key wrap. You have a symmetric key and you encrypt it using HSM level, blah, 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 all that fancy stuff. So you're good in the data center. You got all these credentials locked away. What happens is when you open your wallet in the web browser, today WebAuthn cannot, across the board with platform authenticators and roaming authenticators, you cannot do encryption, decryption. There's something called the PRF extensions, but it's not widely available. So what we do is instead we open the web wallet, that authenticates you to the wallet on the server, basically say this is me, and you pass along part of the initialization vector into the server. And then you pull out that encrypted storage, that purple thing, and decrypt it, and you get a still encrypted thing that can now again be decrypted using a symmetric key that was inside, and then you get the yellow stuff. So using something you have on your phone, the part of the initialization vector, which is not meant as a secret, if IVs are not meant meant to be secret. But in this case, it works fine. Everything is encrypted on the server with the right kind of HSMs and everything. And then you decrypt it using that part of the IV. And finally, you have something that's the credential that you're going to issue. And alongside with that, you kept a key pair, a soft key pair, which is not good. And then you use that to sign and present a credential. To some of you, this might make some vague sense. But anyway, I know I'm not... we should use more time on that. On the right, it says sign with the key pair that was kept inside the purple stuff. That's basically what it says. Really, that should happen in the browser using WebAuthn. So regulators should think about phishing more than they do. They should think about building for the masses, not for the few German politicians that need high security. And they should think hard about UX. I heard Google earlier this morning talking about all the studies they did around passkeys. So, and this is foreign territory for regulators. It's much easier to lobby a regulator to say you need to buy this particular HSM. So that's what happens. And this is personal. You need to stay in the browser as much as possible. If we could do this in the browser, we're much better off. Finally, for FIDO and the platform vendors, again, I would love to see WebAuthn extended with a genuine raw signing option and an encryption option that's widely available across the platforms and roaming authenticators. Attestation would be great too. That would help a lot. If we could get attestation around the key pair that we were issued. And then again, keep it on the web. Some of you may have heard something, it's been coined Credentials API. It's wallet invocation stuff that's coming instead of traditional app switching, which is error prone. There's a new API coming where you can basically talk to the app from the browser without having to do app switching. That's very important that we get that right, and we get browser wallets involved in that. And I think that's basically what I had. Now minus 9 seconds overtime. Oh, I guess that's 9 seconds overtime. Yeah, thank you.
All right, thank you, everyone. Just a reminder, since we didn't have time for questions, if you do have questions, please move down to the speaker area at the end of the hall. All right, thank you, Niels.
Thank you. I'll just leave this one, yeah.